Today we're going to be talking about doing the integrals of du over u. This is basically the opposite of doing the derivative of natural log. So one thing that we have actually avoided doing is ever taking the integral of 1 over x. Because if you think about it, if we rewrote that, it would be x to the negative 1, and then it would cause a problem, because if we add 1 to the exponent and then divide by that number, we end up with x to the 0 over 0. And we can't divide by 0. It is undefined and we cannot divide by 0. So we've actually never had that one come up before, just for that reason. So it requires a special rule. So like I said, if you think about just going backwards, we know the derivative of the natural log of x is equal to 1 over x. So it stands to reason then that the antiderivative of 1 over x is the natural log of x, plus c, of course. So that's the rule for integrals. Integral of 1 over x dx is the natural log of x, and the integral of du over u is the natural log of the absolute value of u plus c. And that's actually one thing you have to add in there, is the absolute value, and I need to put them back here. The reason for that is the domain of natural log is only positive numbers. So since we're switching from a function that can have negatives, du over u, back to one that cannot have negatives, we have to do the absolute value sign. So just remember to put the absolute value sign when you're doing this. Alright, so let's try an example. We're doing a form of Usubstitution here, just so you know. Let's say we have the integral of 2 over x dx. Well, remember we can pull the 2 out front, so we get 2 times the integral of 1 over x dx. And according to the rule, we know that the integral of 1 over x is the natural log of the absolute value of x plus c. So sometimes you may just need to pull a coefficient out front in order to make it work. Okay, next let's try the integral of 1 over 4x minus 1. This is one where you do need to use Usubstitution. If you remember back when we first started Usubstitution, I told you you needed to look for something inside a power, a radical, a trig function, or a denominator. So this time our u is simply our denominator. Our du would be 4 dx. Divide both sides by 4. And we get 1/4 du over u. One thing I do want to say here, you can write this as 1 over u du, and that's the exact same thing. So if you want to write it that way, that's fine. You just got to remember that this has the same rule as this. So either one is the same thing, and you can apply the du over u rule either way. I will generally write it this way with the du over u. So the antiderivative of du over u is the natural log of the absolute value of u plus c. We get 1/4 times the natural log of the absolute value of 4x minus 1 plus c. Okay, so now we will try another one. We'll do the integral of x over x squared plus 1 dx. Again, you choose your u to be the denominator. Your du will be 2x dx, which matches what we have, except we don't have a 2, so we have to divide both sides by 2. And then we end up with 1/2 integral of du over u. Okay, so we end up with 1/2 natural log of the absolute value of u plus c. And then we plug our u back in. Natural log, absolute value of x squared plus 1 plus c. Hopefully the pattern's becoming very apparent to you at this point, but we're going to do a few more examples and then look at one or two things you kind of have to watch out for. So first, just some more examples. Let's say we have the integral of 3x squared plus 1 over x cubed plus x plus 1 dx. Again, choose your denominator is u. The derivative of that would be 3x squared plus 1 dx, which matches our top exactly. Just gives us du over u. The rule for that is the natural log of the absolute value of u plus c. So we get the natural log of the absolute value of x cubed plus x plus 1 plus c. Alright, next let's look at one with trig in it. Let's do the integral of secant squared over tangent x. We choose u as the denominator. Du, the derivative of tangent, is secant squared. And you can see that's a perfect match, so we get du over u. The rule for that is the natural log of the absolute value of u plus c. So we get the natural log of the absolute value of tangent of x plus c. Okay, I'm just going to show you one more basic one and then we'll look at some trickier ones. Let's say we have the integral of x plus 1 over x squared plus 2x dx. Choose u as the denominator. Find the derivative of that and you get 2x plus 2 dx. Now that doesn't quite match what we have on top, but if you look, we can get it to match by dividing by 2. So divide both sides by 2, and we get 1/2 times the integral of du over u. So that's 1/2 times the natural log of the absolute value of u plus c, or 1/2 natural log of the absolute value of x squared plus 2x plus c. Okay, one thing I want to warn you about. This answer is perfectly good and fine, but especially when you have multiple choice questions, you got to watch out because they may rewrite this. Because if you remember, the properties of logs allow you to move this up as an exponent. So this would also be equivalent to writing the natural log of the square root of x squared plus 2x plus c. So if you're just writing it out for an open-ended question, both are equally good. There's no reason you need to move the 1/2. Just keep in mind that's the same thing in case a multiple choice is converted it. Okay, one thing I want to warn you about. Let's say we have the integral of cosine x over sine squared x. Excuse me. If we choose u equal to sine x and du equals cosine x dx, because that's the derivative of sine, we have a perfect match, but look carefully. We end up with du over u squared. This is not the natural log rule. Okay, the natural log rule is only du over u. Okay, it can have coefficients, that's not a problem, but if there's any square root or power or anything on that u, it's not the natural log rule. So for this one, we would just use what we've been using all along. You bring up the u squared as u to the negative 2, add 1 to the exponent, divide by that number, and your answer would be that. So lots of people, partly because the du over u rule is so simple, as soon as they ever see du on top and u on the bottom, they want to do that rule. It doesn't work. You can only use it with du over u. If u has any power other than 1, it's not the natural log rule. Okay, one last example. Let's do the integral of 1 over x natural log of x. So I'm going to go ahead and tell you, anytime you see the natural log of x in your problem, it will be your u. I don't know of an exception to that ever. So if you see the natural log of x in your problem, it will be your u no matter what. So we choose u as the natural log of x. The derivative of that is 1 over x. Now it may not immediately look to some of you like we have 1 over x, but we do. Let me rewrite this. We can write this as 1 over x times 1 over natural log of x. So hopefully now you see that we do have 1 over x. And then you don't have to do this step, but I'm just going to switch them over. So hopefully now you can see it's very clear. Our du does match exactly. So now we can substitute and we get 1 over u du, or du over u. It's the same thing. So we get the natural log of the absolute value of u plus c, and then we plug in our u, we get the natural log of the absolute value of the natural log of x plus c. Okay, that's it. So just watch out for things that aren't exactly du over u, and also watch out for having a natural log in there. If you have natural log in a problem, it will be your u. So for practice, I'd suggest you go to page 330, number 1 through 11, and then 19 through 22.